Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Greek Fire by Megan33. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. The digits along each arrow must sum to the digit in the circled cell. So, for example, if this were, say, 5 and 2, this would have to be 7, because the digits along the arrow must add up to the digit that is in the attached circled cell. And we have digits along each thermometer must increase starting from the bulb end. So you could have something valid like 3, 5, 7, 8. And that would be valid because it's consistently increasing from the bulb to the tip. What you could not have, though, is something like 3, 8, 7, 8, because it's decreasing from this 8 to that 7, and that's not allowed along the thermometer. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this digit is the same as that digit. This is a sum of 3 unique digits. This is a sum of 3 unique digits. To be the sum of 3 unique digits, it must be at minimum 1, 2, and 3, which adds up to 6 at least. So this must be 6 at least here. Same with this. And these 3 digits plus these 2 digits must add up to at minimum 1, 2, 3, 4, and 5, which is 15. Well, this is 9 at maximum, so this also has to be 6 through 9 to add up to at least 15 here for these 5 cells, right? What else do we have? Going from here, for all the 5 length thermometers, these must be 1 through 5, followed by 2 through 6, followed by 3 through 7, followed by 4 through 8, followed by 5 through 9. But this cannot be 6 here because that would force us to be 7, 8, and 9, which would eliminate all possibilities for this cell here. Same with this. If this is 6, 7, 8, and 9, that would eliminate all possibilities for that cell there because all of these cells would see that cell. These are in the same box. This is in the same row. So this cannot be 6 here, which means this can't be 5. This can't be 6, which means that can't be 5. Hmm. What else do we have? So these digits have to be 1 through 6 to add up to at most 9. So 6 is the largest digit here. These 2 digits are the same, obviously. And it has to be one of these 3 digits there. This is 1 through 6 here, followed by 2 through 7, 3 through 8, 4 through 9 there. Now that's interesting. Okay, if this were 4 here, okay, so anytime you have 3 unique digits adding up to another digit, you have to have at least 2 of those digits be from 1, 2, and 3. And the reason why is 6 is a sum of 1, 2, and 3, which has 3 digits from 1, 2, and 3. 7 is a sum of 1, 2, and 4, which has 2 digits from 1 through 3. 8 is either 125 or 134, both of which require 2 digits from 1 through 3. And 9 could be 126, 135, or 234. All of again, which require 2 digits from 1 through 3. You could have this be 9 and 9 here. Are you guaranteed digits from 1 and 2 on these arrows? So, okay, the problem with this being 2, sorry, this being 4, is if this is 4, this would have to be 3, 2, and that's 1, but the 2 and 3 would eliminate 2 and 3 as possibilities here, which would mean this would have to be 1, 5, and 6 at minimum, which is obviously too big for a digit. So this cannot be 4, which means that can't be 5. Same problem here if you have this as 3, right? If you have that 3, that guarantees 2 there, and so that's a problem. But this could be 2 or 3 here. Um, hmm. So to add up to 18, could you have it without a 1? No. 2, 3, 4, 5, 6 at minimum adds up to 20. What about adding up to 18 without a 2? That would mean the minimum would be 1, 3, 4, 5, 6 for the 5 digits in box 7, which adds up to 19. So we are guaranteed 1 and 2 have to be in these 5 cells here. Guaranteed. Okay. What else do we know? Obviously, these could be 3 through 9 for these arrows, because you could be 1 and 2 at minimum here. This is interesting. Where is 1 in column 7? It could only be here or one of these two. Well, You could have 1, 2, 4, 5, 6. So you could have 4, 5 here and 1, 2, 6 here, adding up to 9 and 9. That could be possible. Remaining digits in this box are 3 through 9. Where is this digit, though? It cannot be any of these 3. It can't be here because of it's already in the column, so it has to be one of these 3 here. Okay, so this one has to be one of these 3, which means it has to be one of those 3 there. This digit is not the same as these two. It can't be any of these cells, so it can't be here, so it has to be one of those 4. One in box 9 can only be one of these 4 cells. One in box 6 has to be one of these 6 cells. That doesn't really tell us much.
This could be 6, 7, 8, and then that's 9. That would force this to be 9 here. 9 has to be one of these 6 digits, or the 5 digits here. These have to be 1 through 8 here. These are 1 through 8 here. This we don't have very much information on. This could be 542. No, if it's 5-4, it would have to be 5-4-3, which would force this to be 1-2-6. But this could be 2-4-6 that way also. Hmm. So 1 as a digit has to be either here or here. 2 as a digit has to be here or here. 3 could be any of these 4 or 5 digits. Sorry. That doesn't really tell us much. Hmm. 9 in row 4 has to be either here or one of these two. That's interesting. So if this is 9, then this has to be 9 there. Okay. Obviously 9 couldn't be here in that case, so 9 would have to be one of these two. Certainly seems possible. 9 cannot be any of these digits here, so 9 is guaranteed to be one of those 4.
Hmm. Hmm. Okay, so if this were 1, this would have to be 1. This would be 2, 3, 4 at minimum, which would add to 9 there. So 1 would have to then in row 9 be here. I mean, that's possible. Um, hmm. Hmm. Uh, um, hmm. Um, uh, hmm. We are guaranteed one of these digits is 1 through 4, but that doesn't really tell us much. Hmm. Well, okay, so one of these digits is 1 through 4 guaranteed, because you have to have that to add up to 9 at maximum. So the only way one of these can be 1 through 5, or another 1 through 4 here, is if this is 5, 6, 7, 8, and 9. So what does that leave? Actually, that's actually a good question. This can't be 8 or 9. So no 8, 9. This is less than that digit, so it has to be 5, 6. This can't be 8, 9. It's 6, 7 as a pair, which eliminates 6, 7 here. So that would force this to be 5, 4. Interesting. So that does not seem to work. This can't... Okay. Right, because you would force this to be 6, 7, 6, 7. This would have to be 1, 2, or 3, or 1, 2, or 4. The 5 here would force us to be 4, so it would be 1, 2, 3. But then the problem is this can't be less than 4 at all. And I think that happens if this is 8 and 9 in general, right? If this is 8 and 9, then this becomes 6 or 7, 6 or 7. This is cannot be... has to be less than 6, 7, and it cannot be 6, 7 because of the 6, 7 pair, so that would force this to be 5, 4, and then this would be 1, 2, 3, but that would be 6, and then this would not be less than 4, 5, which fails. So this can never be 8 here. So this can't be 8, which means this can't be 7, that can't be 6, this can't be 5, which means we have four digits here from 1 through 5, and this must include one digit from 1 through 4 here. So because this has to include one digit from 1 through 4, the remaining digits in this row have to be 6 through 9. So this can't be 5. And so this can't have 4 here. So this is 1 through 3 with 6 through 9. This is 6 through 8. So this has to be 1 digit from 1, 2, or 3, and 1 digit from 6, 7, or 8, which makes this at least 7, 8, 9 here. So we have 6, 7, 8, 9 here, 6, 7, 8, 9 here. One of these then has to be a 5, and then one of these has to be a 4, because 4 cannot be here anymore, because if you have a 4 here as the minimum digit, it must be with a 5 to add up to 9, but we're guaranteed one of the 5s has to be one of these 4 cells. That's why the 4 can't be there, so we are guaranteed a 4 here. We are guaranteed a 5 in one of those 2 cells. Interesting. Can this be 7 and 9? Probably. That forces this to be a 6-8 pair. But then that forces this to be 5, 4. Then this would be 1, 2, 3, but you'd have the same problem here. So maybe the answer is no. Can this be 6 and 9 then? Probably the answer is no. If you have 6 in, or whatever, 6 in whatever variable, that would always guarantee this is 5. That's 4. That could work if this is 1, 2, 6 here, right? So if we have 9 available here, okay, well, so can we have 7 and 8 here? If this is 7 and 8, that forces this to be 6, 9. That forces this to be 5. We have 4 here. And this has to be 9 with 1, 2, 6, because that would force this to be 3. And that could work. So this would be 9 in that instance, and this would be 1, 2, and 6. So this would have to be 6. We have to have a 5 or 4 here, so this is 5, that's 4. This has to be 6 then. So there's no 3 or 6 here. Can't be 6 or 7, it's 8 and 9 there. No 5, 6, or 7, no 5, 6, or 7. This can't be 8 because it would force this to be 9, and that would eliminate all possibilities for that cell. Okay, so no 7 here, which means this has to be 1, 8 as a pair to add up to 9. So that does work. Okay. Kind of the question is, can we ever have 4, 5 here? Oh, this is problematic. If this is 6 or 7, this has to be greater than 6 or 7, and these 3 digits already require 6 or 7. 3 out of 6, 7, 8, 9 here. So this can never be 6 or 7, because if this is 6 or 7, this would be greater than 6 or 7. We'd have 5 digits, 5 cells requiring 4 digits in that box, which is not allowed. So this can never be 5 here. I guess the 4 doesn't actually have to be one of these two. The 4 could be here. Okay, so this is... We don't have a guarantee this is 4. So this is not necessarily 4. 4 could be one of these two also. But since this can't be 5 anymore, where's the 5 in row 4? It must be here. So that's 5, which makes this 6, which makes that 7. This cannot be 7 and 9, because we tried to have 7 and 9 here. That forces this to be a 6-8 pair. That forces this to be 5. And if we have 5 and 4 here, and then 6 and 8 as the only options, you can't have 1, 2, 5, 1 through 4 adding up to 8. So it would have to be 1, 2, 3, but then that would eliminate all possibilities for this cell. So this must be 5, 6, 7, 8. This can't be 7 or 8. This can't be 7 or 8. We have a 6 and 9 pair here, which eliminates 6 and 9 in the rest of the row. So this can't be 6, 7, or 8 here. It's guaranteed to be 5. That's 4. This can't be 4 here. So to add up to 6, it would have to be 1, 2, 3, but that would eliminate all possibilities for that cell there. So this must be 1, 2, 6, adding up to 9. So we have 1, 2, 6 there. Obviously, this can't be yellow anymore. And this is 1, 2, 6, which eliminates 1, 2, 6 in the rest of the box and column. So this can't be 2. That means this is 3. This cannot contain 6 or 7. It has to have an 8 with the 1 or 2, so it must be 1 and 8 here. That means this can't be 1, can't be 4 or 3 because it's not less than 3, so this must be 2, which leaves that as a 4. So 9 eliminates 9 here, so it's 6. Neither of these can be 9, so where is the 9 in row 4? It must be here. This can't be 8, it's a 6, 7 pair here. And this has to be 7, 8, 9 here, which eliminates 7, 8, 9 in the rest of the box. So this has to be at most 1 through 5 here. There's no 6 here. There's no 9 here. This is at minimum 3 and 4, adding up to 7. So this cannot be 6 there. Well, it couldn't be 6 anyways. We have 5, 6, 7 here, which again eliminates 5, 6, and 7 in the rest of the column. Remaining digits in box 4 have to be 1, 2, and 8. There's no 8 here because of 8 in the row. 4 eliminates 4 here. This cannot be 6 or 7 because of 6, 7 in the column. This can't be 8 because if it's 8, that would force us to be 9, which would mean there's no possibilities for this cell there. This cell must be less than 3 or 4. So it's 2 or 3. This is less than 2 or 3, so it's 1 or 2. And in row 1, we have 5 cells, which must be from 1 through 5. That eliminates 1 through 5 in the rest of the row. So that's 6 through 9 here, 6 through 9 here, 6 through 9 here. This can't be 6 because of 6 in the column. And where's the 5 in row 1? It has to be one of these two cells. Well, if it's 5 here, to add, this can only add up to 6 at most. So this must then be adding up to 6 because there's no other possibility. So this is 6, this is 1, 5 as a pair. That eliminates 1 here, so this is 2. That's 3, that's 4. And this can't be 4, it has to be 8 or 9. Okay. Remaining digits here are 2, 3, and 4, and this digit must be greater than that. So this can't be 2, this can't be 4 for that reasoning. This can't be 2 here because of 2 in the column. There's no 3 here available. Okay. Remaining digits in box 5. We have 1, 3, 5, 7. No 3 here, obviously, because of 3 in the column. Remaining digits in column 7. We have 1, 2, and 3. So this cannot be 3 here. It can't be 2 here for the same reasoning. This can't be 3, because if this is 3, this is guaranteed to be 1 or 2. So 3 is not here, which means this can't be 3. So this is 1 or 2 here. If this were 3, the problem is this would guarantee be 1 or 2, and then we'd have 4 cells requiring 1, 2, or 3 here. Okay. This must be 3, 4, or 3, 5, or 4, 5 here to add up to 7, 8, or 9, because we can't have 1, 2, or 6 there. We have a 1, 2, 3, 4, 5 quintuplet in row 7, which eliminates 1, 2, 3, 4, 5 in the rest of the row. So this cannot be 1 or 2. It's 6. This can't be 3, 4, 5. It's 7, 8, and 9. And this is 7, 8, and 9 here. This can't be 9 because of 9 in the column. So 6 cannot be here. We have a 1, 2 pair in row 8, which eliminates 1. And this one cannot be here. So it has to be here because it is a guaranteed 1 or 2. Okay. You cannot have 6 here because that would guarantee this has to be a 1, 2 pair. Actually, you can't have 6 here at all because that would guarantee this is 1 or 2. So we're guaranteed that you have to have a 3 on this arrow because this is 1 out of 1 or 2. Therefore, we have to have 2 digits from 1 through 3 here to add up to the 8 or 9. And therefore, one of these is a 3, which eliminates 3 in the rest of the column. This again cannot be 3, because if that were 3, this would be 1 or 2. We'd have 4 cells requiring the 3 digits, 1, 2, and 3. This must be greater than that, can't be 4. This must be greater than that, can't be 4 or 5. This must be greater than that, can't be 5 or 6. We have a 6, 7, 8, 9 quadruplet. Actually, we have a 7, 8, 9 triplet in row 9, which eliminates 7, 8, 9 in the rest of the row. This can't be 7, 8, or 9. It's 6, which makes this 5, which makes that 4. That means this can't be 4 here. We have a 1, 2, 3 triplet in box 9, which eliminates 1, 2, 3 in the rest of the box. So this must be 7, 8, or 9 here. So we have a guaranteed 7 here. That means this can't be 7 there. 6 eliminates 6 here. Where is the 6 in row 1? It has to be here. So we have a guaranteed 7. This is 1 and 8 adding up to 9. So this is 9, that's 8, this is 9. So this is either 1, 2, 1, 3, 5 or 2, 3, 4 adding up to 9 here. This cannot be 9, so where is the 9 in box 7? It has to be here. So this is 9, which eliminates 9 there. This then adds up to 7 or 8. This can't be 9. This can't be 9. So we have a 7, 8 pair here, which eliminates 7 and 8 in the rest of the column. This can't be 7 or 8. It's 1, which makes that 8. That eliminates 1 from being here. So 1 is guaranteed to be one of these two, which means this can't be 1. We now have a 2, 3 pair in row 3, which eliminates 2 and 3 in the rest of the row. So this can't be 2 or 3. It's 4. That makes this not 4, so that's 3. This is 2, that's 3. This can't be 3 here, so this must be 1, 2 as a pair, which eliminates 1 and 2 in the rest of the box. So this can't be 2, it's 3. This can't be 3 or 4, it's 5. So 5 and 3 add up to 8. So that's 8. This is 7, that's 8. This can't be 7 or 8 here. This can't be 3 or 5, so this has to be a 4. That means this can't be 4 here. This can't be 3, 4, 5, or 8. It's 7. 3 eliminates 3 from being here. So where's 3 on this arrow? It must be here. Okay, 5 eliminates 5 from being here. So if this is 1, 3, 5, it has to be 1 here, 3 here, and 5 here. 7 eliminates 7 here. Where is the 3 in box 5 now? It has to be here. Where's the 3 in row 6? Can't be here because the 3's in the boxes. Can't be here because 3 in the column. 3 has to be here. Remaining digits in row 6 are 2 and 5. Can't be 5 here because of 5 in the box. So that's 2, which makes this 1, which makes that 5. Wait, we already have a 5. Okay, this can't be 5. It's 1, which makes this 2. That leaves this as a 4. There we go. And this has to be a 2, 9 pair. This can't be 9 because of 9 in the column, so that's 2, that's 9. 8 and 9 eliminate 8 and 9 here. So it's 7. There's no 7 here. No 8 here, no 9 here because of 8 and 9 in the row. We have 1, 2 as a pair in row 8, which eliminates 1 and 2 in the rest of the row. So this cannot be 1 or 2. It's 4, which makes that 2, which makes this 1 and that 1. That's 2. Therefore, this must be 1 here. That's 2 there. Remaining digit in row 9 is a 5. Remaining digits in row 8 are 6 and 9. And this can't be 6 because of 6 in the column. So that's 9 and 6 there. These can't be 1 because of 1 in the box. 2 eliminates 2 here. 5 eliminates 5 here, so this is 1 and 5. 1 eliminates 1 here, so that's 8 and 1. 6 eliminates 6 here, so it's 7 and 6. 9 eliminates 9 here, so it's 8 and 9. 9 eliminates 9 here, so it's 7, which makes that 8. 8 eliminates 8 here, so it's 7 and 8. And the rest is just normal Sudoku. This has to be 1 here, whereas 2 in this box we cannot have 2 here because of 2 in the row, so 2 has to be there, which makes that a 5. 1, we have 8 ones. We know where the last one has to be. It's there. I think we have all 9 2s. We do. 3s, we have all 9 3s. 4, we have 8 4s. The last 4 is there. 5, we don't have enough information. 6, we have 8 6s, so the last 6 has to be there. 7. In row 3, 7 has to be there, which makes this 5, which makes that 7. So that should be all the 7s. 8s, we have all 8 8s. 9, we have 8 9s, so then the last 9 has to be there, which leaves this as a 5. That was actually really interesting. Yeah, the logic behind this was very interesting here because of the way that this worked. Particularly this part, right? If we tried to have 5, 6, 7, 8, and 9, or just the 6, 7, 8, 9 got eliminated by that possibility there. But the way that this thermometer interacted with this was very interesting. And then you had this arrow, which was interacting with these very interestingly too. Interesting little setup. Well constructed, and it was... The break-in was a little difficult, I will say. But once you find it, everything flowed very well from it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.